a big data is nothing but a data which is huge in size, is called a big data, nothing else. So there are many definitions also. If you go ahead with any of the specific tools, there will be some definitions, but definitely a big data is nothing but a huge amount of data, which cannot be processed with traditional tools that we have, like SQL Server or any normal traditional tools which we use for processing data, which are not capable of handling big data. Uh, the data which is used is called big data, kind of that. So what is big data and how does it what does it mean, like how it comes? So the big data is mainly followed with um, 4 V's. Actually, it is 3 V's now. This V has got included veracity. Okay. Before that, only 3 V's were there: volume, variety, and velocity. So volume means the amount of data, variety means the types of data, and the velocity means the speed of data that comes into the system. And the veracity which gets included in this is like which is responsible, or which you can say like um, quality, consistency, and the reliability of the data and the provenance. So these things are the core. Like, what is big data? So big data is a huge amount of data which comes from these 4 V's. Okay. So here you can control. Here you can control volume of data. That's fine. We can have a huge servers to handle the volume of data, but velocity of data also you can handle. But the variety of data is not possible to handle with a single system, right? So Hadoop gives you a platform which is like which can ingest any type of data, which is like it eats up any data. So whether it be like text, audio, video, streams, flat files, whatever. Okay. So in the current world, like 80% is the unstructured data, which is nowhere used. Only 20% of the structured data is used for business insights. Like whatever we do reportings, right, every time, it is just the 20% of the data that we get from the current existing systems. So where do we use big data? These all are the examples: social media, IT, finance, telecommunication, media, life science, retail, and the search engines like Google, Yahoo. So those are indexed. And do you know any of the indexing tool that is available in market?
No.
Have you heard about Elasticsearch?
Elasticsearch, no. Not it.
You can Google it. That is actually a very useful and freeware tool which is used for indexing. And there is a tool called.
So can we plug into like any of the databases like DB2 or
yeah, we can plug it and we can do the indexing part. So if you have any huge amount of data that needs to be indexed, and those data are already residing in some database, so then you can just use some drivers of those database, connect it with Elasticsearch and index it.
Okay, so it's called like Elasticsearch.
Yeah, and the paid version, there is a paid indexing tool is called HP Autonomy. Have you heard about that?
No, HP
That is
Autonomy.
actually, yeah, that is actually Autonomy is a company which was acquired by HP, so it's called now HP Autonomy. It has a product called IDOL, which is also a search engine indexing kind of tool. So so these things
what
are
you
like
say like so what you said earlier, it's a
Elastic
Elasticsearch. Okay. Okay, so if you want to go for the like license one, so we need to buy that one and we need to plug in, right?
Yeah, even Elasticsearch, if you want to get the enterprise version, you have to pay.
Okay.
But if you are okay with the free version and you are ready to handle the like flaws, everything by your own, then it's fine.
Yeah, but thing is like when you're proposing to the client and when you're at the client side, so you can't when you're
Yeah,
yeah,
at least for the
yeah,
POC stuff and everything for
yeah,
making
for
the
development
demo.
and UAT it should be
Uh,
fine, but whereas for production you need to have the license one, right?
yes, correct.
Yeah.
So challenges challenges in big data storage
So
is
like
and
so
analysis.
before that, so like generally like how much it would cost like for that one? Is it like a huge
I
money
have
or
no
like a
idea.
okay,
Actually, Elasticsearch we are not using. We are just exploring something on that. But, we
okay,
are using it autonomy, so idle. So it should not be much costly. It is like not very costly.
okay. So which sorry if you don't mind like so which company you're working?
Uh,
Okay, HP. Okay, so they bought this one and they're using it. Okay.
yeah. So see, challenges for the big data is like the storage, which is actually not a challenge for big data because it uses a cluster type of thing, which is anytime where you can add more and more space to perform the analysis. Okay, and failure is the main challenge. Failure means like any time any machine can go down, right? And the data inside that can be like that can go for toss. So that is a challenge. The speed is also the challenge. Like if you have huge amount of data processing, and if that speed of that data transfer is not so good, then it will take a lot of time, right? So these are the some of the challenges.
Mm-hmm.
Then the reliability is also what I told. Backup, not affordable, expensive. Uh, then easy to use and secure.
Mm-hmm.
Process data in parallel. So what is the advantage here is it is easy to use, process the data in parallel so that only one machine will not be actually doing the part, will not be responsible for completing the job.
Mm-hmm.
So what does it mean, process data in parallel? So it actually, uh, let's say you have a calculation to be performed, okay, and you have only three machines, and you initiate a job to calculate something, okay, to compute something. So what will happen? All the three machines will be responsible and will be calculating, doing the job on the separate individual hardware.
Mm-hmm. Okay.
So anytime, assume first machine completes their data processing and the second machine also, but the third machine fails. What will happen? Will you get the output?
Mm-hmm. No.
You will get the output because first and second was has completed their jobs and the third one will get down and it will give you a response that I am down, take please take care of my job. So any one of the first and second machine which will complete their job first will take the job from the third machine. So that is how
Okay.
the replication factor also helps. So all the three machine will have all the three data. Every machine will process their own part of data. In case
Okay, so
anything
it's like
fails,
so three data the data will be split into three parts.
you can say three parts residing one copy each. Then
Hmm.
there is no um, replica of the data available. In that case, if any machine get fails, you will lose the data. If all the three machine have copy of the data, okay, replica of the data, in that case any machine fails, then you will get the data back.
Okay.
Means the processing will happen and it will give you the data. That is handled by um, framework itself, Hadoop framework.
Mm-hmm. Okay.
And this type of working is called speculative performance. So what will happen if any machine which is performing and it gets fails, other machine will take care of the job.
Okay.
Or not only in the case of failure, but in the case of slow performance also. Okay. you have two machines, but one of the machine is already occupied with some other job. So when you put another job there, it processing it slow, or because of any hardware or malfunctioning, it is processing very slow. Then what will happen? The first machine will finish a job and takes the part of the job which was there in the second machine, so that it could be finished earlier.
Okay.
So resource sharing, concurrency, fault tolerance, heterogeneity, transparency, these are some of the challenges in distributed computing.
Mm-hmm.
Hadoop origins. So from where we got Hadoop? You know the person who invented Hadoop?
No. So
It's
I don't have any knowledge on
dog
Hadoop.
cutting.
So you need to teach me
Yeah.
like from basic thing. Yes.
So it's dog cutting who was actually an employee of Yahoo at that moment when he quit, and he started his own project under Apache license. Um,
Mm-hmm.
and it has it works same as what we have as Google. So Google uses almost the same technologies which Hadoop uses.
Mm-hmm.
Google, which is called Google File System, and Hadoop is having HDFS, Hadoop Distributed File System.
Okay.
The person who invented the framework is called dog cutting, and all
Mm-hmm.
this, even the Google systems and even the Hadoop systems resides on commodity hardware, means the hardware cost is very cheap since it's a kind of slave. So all the machines which are slave need not to be a very high-end model, high-end machines. It can be
Mm-hmm.
any machine, just it should have their own capacity of holding data and processing it.
Okay.
Um, the history behind the name Hadoop is that guy uh,
Mm-hmm.
Dog Cutting, who was the inventor of this one, his child was playing with a soft toy yellow elephant. Since
Okay.
elephant is a animal which is huge, right? So
Mm-hmm.
that kid was calling it as Hadoop Hadoop.
Mm-hmm.
So he got this name from his kid, and it started this project as Hadoop name.
Okay.
There is a lot of thing in this slide, but I can skip it and you read it anytime. It is just for reading purpose. So there is a question, right? What will happen if um, is it Hadoop going to replace RDBMS? Kind of question always arises. So the question is no, because RDBMS and Hadoop works entirely in different structure. RDBMS is a relational database management system, which is working on the related data, right? It it
Yes.
should have a structure, otherwise it won't work. But the big data is such a kind of thing which can work on semi-structure as well as unstructured of data. Although you can store any type of structured data in any form in Hadoop, but it is mainly designed for unstructured and semi-structured data.
Mm-hmm. Okay.
Can you give an example of semi-structured data?
What you get from the feeds basically, from the Facebook feeds or
No, those are unstructured.
semi-structured like
See, what you get from the social network feeds and like logs, those are unstructured because it is not having any format. It doesn't contain anything. If you see the logs, it will be like timestamp colon and then everything
hmm,
written in a single line. If you see uh, social media feeds, you will have a lot of information separated by anything, colon, comma, whatever. But
mhm,
the semi-structured file is a file which is having a structure, but it is not fully structured to be directly consumed by any RDBMS, like
mhm,
XML files. XML is actually a structured format, right? You have
Mm-hmm.
everything proper. If you have tags properly defined. If there is no tag properly defined, that XML won't work, right?
Yeah. Yeah.
And you have JSON, which is also well defined. Means uh, it has everything in curly braces, which will be like first object will be your key, after colon whatever the data is there, that is your value. Means it stores the value in key value format included in a curly braces. Means inside a curly braces one record will be there. Means it is properly defined. If in curly braces is not there, that JSON is not going to work. So
Mm-hmm.
like sort of that. So you have many other examples of semi-structured data. Means it has well defined form, but it cannot be consumed directly by any RDBMS.
Okay.
So how we can use Hadoop and RDBMS? So we can process anything in Hadoop, okay, and the output can we can redirect it to the database storage to RDBMS, because RDBMS are well known for doing the analytical stuff, right? Because it is
Mm-hmm.
structured and we can apply any kind of analytics operations on the structured data.
Mm-hmm. Okay.
So Hadoop architecture is like it consumes mainly of two things. Sorry, it consists of mainly of two things: HDFS and the MapReduce. I'm sorry,
Okay.
HDFS and
So,
MapReduce.
so instead of like going through this, like all this full presentation, so don't you have like a shortcut version of the presentation, as in a simple
Shortcut.
terms?
I'm not going through each of the lines. I'm just giving you what is the architecture. So anyway, it is all almost end. There is nothing more.
Okay. So you said like map reduce hive
Yeah, I'll give you. That
as
is coming up.
yeah, okay.
So uh, that was the introduction. Now whatever is coming is the framework. So you have Hadoop as HDFS plus MapReduce. HDFS is the storage part where the distributed file system resides. It is virtual, okay. And MapReduce is the programming model which process the data as a distributed computing system,
Okay.
okay. And Hadoop comes with master-slave architecture. So one machine will be master and other machines will be slave, okay. Master doesn't perform anything. Master just keeps the metadata information about the complete cluster, and the slaves node, which will actually do the operations. Okay, so if
Mm-hmm.
you see this diagram here, the name node is the data node. Sorry, name node is the master node. Okay, which is actually holding all the metadata information about all the slaves available. Okay, all the slaves are data nodes, and the secondary name node is just like a periodic checkpoint which will take replica of this thing here, but it is not a backup of name node. Okay, if anything happens to the name node, you can use the file here to restore it back here. Okay,
Mm-hmm.
that is the architecture. For this architecture is for Hadoop 1.xx versions, means Hadoop 1 version. There is another architecture of Hadoop, which is recent one, is called Hadoop 2, which will actually have the federation of name node. Means the name node will not be only one machine. There will be 3, 4 machines, but the amount of data will be means the amount of metadata information will be restricted. Means first name node will contain only this much, and like the uh, first name node will contain 10 node information, second will another 10 node, and so on. And they will be like swapping each other information. So any point of time any name node goes down, the other name node will um will take up the responsibility for that name node.
Mm-hmm. Okay.
So that is like more safe to failure. Like failure will not be very common in there, but in Hadoop one, failure is there. It's a single point of failure. Means if name node is down, everything is down in Hadoop one.
Okay.
Similarly, you have master, the same master node will have another component called job tracker,
Mm-hmm.
which will actually get information about all the jobs and distribute the jobs about in all this task tracker. Task tracker is nothing but the data node where actually the task is going to perform. The job will actually divide the job into many tasks and put it to different task tracker, and um, each task tracker will performs it separately.
Okay.
Okay, any question till here?
Now, if you just go back to the previous slide, so where you talk about the map reduce.
This one?
Yeah, so you said like MapReduce is basically a Java programming.
Yeah.
So and it's also like a framework to to distribute the workload, right?
Hmm. Yeah.
Okay.
Correct.
So
That
my question is, yeah, so it's saying that it's already a framework. The framework is like a Java or something, right? So within
it's a
the
frame.
framework, like there will be a Java programming to distribute the workload.
Yes, correct. So, see, the internally it works like this. So when you submit a job, let's assume you submitted a job in Hive. Okay,
Mm-hmm.
that Hive, whatever the syntaxes you have written, that will convert into Java program and it will get converted into jar files. Okay, and the jar
Okay.
file, assume like you have 3 node cluster. So that jar file will get distributed to all the 3 nodes. Okay,
Mm-hmm.
and the jar file will contain the information what you need to perform in each of the nodes.
Mm-hmm.
Okay, so that is how the work is getting distributed. Means in a normal traditional distributed computing system, what was happening here is the data which is residing on the slave nodes that moves to the master node for processing, right? And then
Mm-hmm.
whatever the output is there, then output will get back to the slave nodes again. But in Hadoop framework, what happens? Data doesn't travel, code travels. Means the jar file travels from the name node, means the master node, to the slave nodes, and the the functions happens only on the slave nodes, and the output is also stored on the slave nodes, but it is consolidated and given to the master node, and which is again sent to the client.
Okay.
Got it?
Yeah.
Okay. So this is ecosystem. You have client which communicates to the master. So master can be your job tracker, name node, or secondary name node. So these all are masters. Secondary name node is a like passive master. It is not active master. Okay, and your data nodes and task trackers are on the slaves. So this person, I'm sorry, name node is responsible for all the metadata information, which data is stored, which location. Job tracker is responsible for if any job is submitted, how to get it executed with all these machines available in the cluster. Okay.
Mm-hmm.
So red is actually HDFS, means this all contains HDFS information. This all contains HDFS information, but this doesn't contain any HDFS information. Okay, since it is
Mm-hmm.
related to job only.
Mm-hmm.
So the development part for Hadoop 2002 or 3 it was actually started as a project, Lucene project, but it came on existence on 2006 as a core Hadoop, and it has expanded so much like 2011 it is here, which we have now as Spark, Scala. These are the new um, ecosystem tools that are getting added into Hadoop ecosystem.
Okay. So what are these like? So when you say core Hadoop, HP, HBase, and then Pig, Hive,
See,
Avro, Flume.
correct. So core Hadoop is nothing but your map reduce programming. Okay.
Okay.
When it comes to 2008, HBase, Zookeeper, Mahout, these 3 things are like HBase is a NoSQL type of database which will which is responsible or is a tool which you can use as storing unstructured data in form of key and value pairs.
Mm-hmm.
Key and value pairs means if you have a complete paragraph, okay, you put it as a value and assign a key to it. So when you query a key, assume like A equals to some 100 lines of text. Okay, so when you query, select A from this table. That means that complete paragraph is going to come.
Mm-hmm.
Okay, it as a very layman language, assume key as a column names.
Okay.
Okay, but it is not exactly the same. It is a different concept altogether. And then Zookeeper is like a management service which manages the complete Hadoop ecosystem. Okay,
Mm-hmm.
means it's like a person in a zoo who manages a complete zoo. In a circus, you have a ringmaster, right? Like that.
Mm-hmm. Yes.
So Mahot is a machine learning program which sits on top of Hadoop architecture. Okay.
Mm.
Machine learning, you are aware of anything?
Sorry?
Machine learning.
No.
It's another very hot topic in market, like very high paying job.
Okay.
Then you have a Pig Hive. Pig is a tool which was uh, developed in Yahoo. Actually, it's a scripting language, just like JavaScript and all other scripting language. It has its own scripts, which is called Pig Latin, Latin Latin. Okay,
Mm-hmm.
so you need not to learn Java in order to work with Hadoop. So Pig, you can use Pig to finish your job. Okay, Hive Hive is um developed in Facebook. Okay, and it is exactly same as SQL. Like if you want to create a table, just write create table syntax, and the table is created. You can write insert statement to put the data. You can write select statement to get the data, like that. You have update.
Okay.
So all the DML operations can be performed, but
Okay.
there is
So
a
in other
difference.
terms, so each one is it's called like a independent function, and it does one activity based on your
Yeah,
requirement.
correct. It's in a ecosystem. All these are components.
Okay. So
Okay.
when you cover the classes in detail, so you will be covering each of the steps?
No, no, I will be covering since if you ask me what is Hadoop, Hadoop is a very big thing and
Okay.
everything is not possible. So here it's the content. Um,
Okay.
Introduction, which is if you just Google Hadoop ecosystem tools, okay, you will get hundreds of tools,
Mm-hmm.
but those all those hundred of tools are not being used, right?
Mm-hmm. Okay.
So Hadoop environment works on three systems: standalone, pseudo-distributed, and fully distributed. So we will be using pseudo-distributed because it gives you a feel of complete cluster.
Okay.
Okay, and this is your features like store anything, storage capacity, data locality, failure and failure and fault tolerance, then cost effective. So these all things are the like features of Hadoop. I'll send you the
Mm-hmm.
slide. You can go through this slide, and if you have any question, you can just ask me anything.
Okay. Yeah, sure. Okay. So can you send me this like today after this class?
Yeah, I will send it to Ganesh here. You can get it from him.
Yeah, sure.
Okay.
Yep.
In order to be a good Hadoop developer, you need three things. First
Mm-hmm.
is Linux scripting because it works on Linux platform only.
Okay.
Okay. Or if you are good with Apple OS, that is also fine
Mm-hmm.
because both are almost same. Second thing is very good in SQL.
Mm-hmm.
And the third thing is you should be aware of Java.
Okay. So the first two is fine, and the third one I need to look into this. Yeah.
That is not so hard. It is like only the core Java is required. Even
Okay,
I don't work on uh, hardcore Java programs. I just work on this other parts of the Hadoop
okay.
tool.
So tell me one thing. So where do we need a Java for this? Is it like for troubleshooting or like fixing the minor things, or
No,
we
no,
need
no.
a
If you are
Java
working on
from?
MapReduce only, then only you need it. Otherwise, nowhere it is required.
Okay, but even for MapReduce, so we need to
You don't
write from a
bother about it.
scratch.
No, you don't bother about it because see, if you are writing Scratch MapReduce program, you should be good in Java. If you are not writing anything on MapReduce, no need of Java at all.
Okay. So
If
do
you
you have
write
any
anything
set?
on Hive, if you write anything
Okay.
in Hive scripts or Pig scripts or Flume or anything, that will get converted into Java itself. And whatever it converts, it's beyond our understanding.
Okay. So do you have any certifications as well?
I have only Mapper certification. Mapper is another vendor like you have Cloudera, Hortonworks, right?
Uh-huh.
So Mapper is another vendor which provides enterprise Hadoop distributions.
Okay. So it's that's equivalent to the this one.
No, no, no. You are not getting it. See, Mapper you have. Um, I'll send you this slide. There is nothing more in this one. So, in
Okay.
like topic wise and concept wise, we have completed everything. So you have to download a VMware player.
Mm-hmm.